Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox. This exercise is titled Pier Bridge Scour at Different Flow Rates. So what we're going to be investigating is the different amount of bridge scour at a pier that occurs at different flow rates. It will involve FHWA project, which we need to set up first to define the geometry and the flow data. And then after that, we will use the bridge scour calculator right here in the hydraulic toolbox. Well, let's go ahead and get started with that first. I'm going to come up to calculators and go new bridge scour analysis. Now, if you haven't already set the units to US customary, that's what I'm going to be using for this exercise. So you can do that in this drop down right here. Here is the bridge scour calculator that we just created. Double click on that to open it up. And then the first thing we want to do is select the geometry from our FHWA file. So import geometry from FHWA, click on import. And then what we need to do is click on browse and navigate to our FHWA.prj file. Now we haven't created that yet, so that's what we're going to be doing right now. And then once it's created, we'll come back to this dialog box, upload the geometry, and then continue on with our bridge scour analysis at the pier. So I'm going to actually close this up and close and minimize that. Here is my FHWA. Let's get started. I'm going to go File, New Project, and then navigate to where on my computer I want to save the FHWA file. Okay, project. I have a dedicated directory here called FHWA, so that's good. I'll just call it project and then click OK. This little warning here is just confirming I'm going to be using US customary units. That's correct. It's labeled right here. And let's open up the geometric data editor and define our cross section. So I'm going to click on river reach, single left click, and then just go ahead and sketch out from upstream to downstream and double click. This is going to be called river A, reach 1, and click on cross section data. I'm going to go options, add new cross section. I'm going to start down here at the downstream end, which is cross section river station 0. Click OK. The cross section has been created. And now I'm going to type in or paste in the cross section data. Click on apply data to actually save it and see the preview over here. If you don't see the preview, you can toggle that on and off using this button up here. So I have a 30-foot wide base to my trapezoidal shaped channel and a 3-to-1 side slope on both sides with an invert elevation here at 120. All right, let me go ahead and fill in some of this other information. I'll say 0.04 is Manning's N. That's the roughness coefficient. And then the bank station, I'll just say it's the total extent. So the main channel is effectively the entire channel. Okay, then click on apply data. So that's been saved. I'm going to create a few more cross sections further upstream. So to do that, I'll just go copy the current cross section. And then I'm going to say the next cross section upstream is at river station 300. Click OK. And then I'm also going to say that the elevation increases by 1 foot. So it just elevation 1, OK. These numbers all added by 1. I could have done that manually because there's only a few numbers, but it's all right. It's good to know how to use the tools as well. So apply data. Next, I'm going to add another cross section, but it's not going to be 300 feet upstream. It's only going to be 50 feet upstream from this cross section. So options, copy the current cross section. That will be at river station 350. Click OK. Oh, something I forgot to do for the previous cross section is the distance downstream needs to be 300, 300, and 300, or assuming it's completely straight, even though that's not exactly the same. It doesn't really matter because I don't have any left or right overbank anyway. So that was when editing the cross section at river station 300. I'll go ahead and apply data. All right, let's go back to 350 now. Now what I want to do is type in 50, 50, 50, and 50. Apply data. And I want one more cross section at the top of the reach. Just as before, that will be a difference of 300 feet. So let's go options, copy the current cross section. 300 upstream from 350 will be 650. Click OK. This is now going to be 300, 300, and 300. We're going to stick with the exact same Manning N values, but I do want to increase the elevation by 1 more foot. So adjust elevations, and then a 1, and OK. All right, so that's good. I'll click Apply Data. That saves it. Plot profile. Here is a profile view of the river reach. So we start at 650, it comes down to 350, and then 300, and then down to 0. So right here, centered at 325, this is where I'm going to add my bridge, which is going to have a pier, which is going to be used by the hydraulic toolbox to calculate the scour around that pier. So we're getting there, but it just takes a while to build up the necessary data for the geometry and all the HECRAS stuff that we're doing right now. So I'm doing this as fast as I can. I'll go ahead and click close. Here is our cross sections we can now see in the plan view. So 650, 350, 300, and 0. Our bridge is going to be positioned right here at 325 between these two cross sections. So I'm going to click on Bridge/Culvert, Data Editor, Options, Add a Bridge. This is going to be centered at 325. I'm going to say the width of the bridge is 30 feet. So if I click on Deck/Roadway, the distance will be 10 feet from the next upstream cross section. So 340 from 350 is 10. The width of the bridge will be 30 feet. And then for the high chord and low chord data, this is what I have prepared. So for the entire width of 100 feet, the low chord is 141, the high chord is 148. I'm going to copy that data to the downstream side, and let's just assume a 3-to-1 side slope for the embankment, both upstream and downstream. Okay, I'm going to click OK. And then here is the updated view for the bridge. We see the Deck/Roadway across the top. Next, I'm going to click on Pier and add a pier. So this pier is going to be centered, which would be at cross-section station 75, both the upstream and the downstream. So we'll type 75 in right there. And then the pier width, I'm going to say, is 4 feet. So I'm going to say 4 and 4. The elevation at the bottom is 121, and then at the top, it is 141. Copy to downstream and click OK. So we now have our one pier, and that is all we need to do for defining the geometry. So I'm going to close that up and then go File, Save the geometry data. I'll just go ahead and call this base. It's going to be our only geometry, so whatever you call it isn't too important. You can see in the plan view that we do have our bridge right here, centered at River Station 325, so that looks good. Next, I'm going to define 3 different flow rates. I'm going to come up to Edit, Steady Flow Data, and then 3 for my number of profiles. They are going to be 1,000 CFS, 3,000 CFS, and 8,000 CFS. Also, I'm going to go Options and edit the profile names. So instead of just PF1, PF2, and PF3, it's going to be, hold on a second, 1,000 CFS, 3,000 CFS, and finally 8,000 space CFS. All right, now if I click OK right here, I now have updated labels. So this will show up on future cables and plots after I run the simulation. It's just a little bit more user-friendly when trying to understand what you're looking at. So you don't have to think back, oh, PF1 is 1,000 CFS, and so on. You can see exactly which flow rate is associated with each profile. Okay. Also, boundary conditions. I'm going to use normal depth. Again, this is the downstream boundary condition because with such a small slope, I'm going to assume subcritical, which we'll check that assumption. So 1 divided by 300 would be 1/3%, 0.00333, and OK. Okay. So OK, and then File. I'm going to save the flow data. I'll just call this base. OK. I could have saved it with some sort of description based on the different flow profile, but I know what I'm doing, and I could rename it later if I want. All right, so close that. Now I'm going to come up to Run Steady Flow Analysis. I have my geometry data and my one and only flow data. So I'm going to go File, Save Plan, and I'll call this Base, and then for the short ID, also call that Base, Subcritical, and Compute. Okay, that ran. I'll click on Close, and then close that. Let's take a quick peek at our results. So I'm going to come up to look at the cross-section data. Then I'm going to go Options and toggle on all 3 of the profiles, 1, 2, and 3. Okay. Okay, cool. So this looks normal. Down here at the bottom, I have the 1,000 CFS water surface elevation, which is currently highlighted in red. And then just above that, this is the 3,000 CFS. And then the top one right here is the 8,000 CFS water surface elevation beneath the bridge. I could change to different cross sections, but I think the bridge is the most interesting. And to confirm that we are indeed subcritical, I could look at table data, but I could also toggle on the critical depth, which is right here. And sure enough, red, that critical water surface elevation is beneath the normal depth for all three of our flow profiles. All right, so that's confirmed. We're looking good. That's in fact all I need to do in HEC-RAS. We may need to come back and look at some data, but for now I'm just going to save it and then minimize it and come back to my hydraulic toolbox. And finally, we'll get started with that bridge scour analysis. So I'm going to check on the checkbox to import geometry from HEC-RAS and then click on the browse button, navigate to that HEC-RAS file that we just created, projects HEC-RAS project.prj. Okay, so that is read in. We need to specify the upstream cross section of 650, and then the bridge cross section that was 350, and finally the bridge itself was at 325. All right. We don't have any abutments, but we do have a pier, and it looks like that data has been copied over correctly. Here it is. The width is 4 feet. The elevation is 121 to 141, and then its cross-sectioning station is right here at 75. Okay, so I'll click OK. Now in the main bridge scour dialog box, let's see here. We need to do a few things. The contraction scour, I'm not going to look at that, so I'll check that off. Bridge cross section and geometry, that's fine. I'll leave that there. Further down, we have the local scour at piers. So that's checked on. That's correct. We only have one pier, and the centerline station of the pier is actually 75. I'm not sure how that got disabled, but that's good. Before we get started, what I want to do is add 3 different scenarios. Right now, it just starts me off with this one generic scour scenario, is what it's called. But I'm going to type in 1000 CFS and then tab off. Okay, so it renamed my one and only scenario. I'm going to click on create and then create again. And now I have 2 more scenarios. So the next scenario is going to be my 3000 CFS. And then the last scenario is going to be for 8000 CFS. Okay, so I have the 3 scenarios. I'm going to click on scenario 1, or 1000 CFS scenario, make the edits for this scenario first, and then come back and make the required edits for the other 2 scenarios. That way we can compare how the bridge scour is different as the flow rate increases. But for all 3 of these scenarios, I don't have to import a new HEC-RAS geometry. That's already been done, and we can move forward with the analysis. Okay, so let's scroll down here to Pier again. Pier 1 is the name. That's fine. Pier geometry, we already have that. The center line, we already have that. Let's double check that we have the pier geometry. Okay, I'm not really sure where this went. I guess I have to redo this. So 2 points. We already saw this was 4 and 4 for the width. The elevation was 121 up to 141. Okay, click OK. Now for the pier scour reference point is currently set to FHWA. I'm going to change this to local. And if you're curious what that means, the user's manual here on page 72, where it talks about bridge scour, specifically pier. We have 2 piers. This left pier is using the local scour reference, and then the pier over here on the right is using the FHWA reference. So FHWA is basically the eroded depth subtracted from the FHWA elevation, this vertical distance here. Local is the eroded depth from the original stream bed elevation. So I've just always had better luck using local. That's what I'm going to do. Okay, let's go back to the calculator now. So local. Now, the only thing we have to do left is click on define for the pier scour parameters. We'll spend the rest of the exercise talking about this dialog box. At the top, we need to input the parameter data, and then down below, we'll get all of our results. Specifically, the scour depth is what I'm most interested in. All right, so pier shape, I'm going to use round nose, but there's a number of other options as well. And then the bed condition, this is the type of water. So we have clear water scour, which means there's no sediment in the water. Now the upstream depth of pier and the velocity upstream of the pier, these are 2 values I'm going to need to get from HEC-RAS for all 3 of my scenarios, 1000, 3000, and 8000 CFS flow scenarios. So I'm going to come back to that a little bit later and then just continue on with the data input. The width of the pier, we know is 4 feet. The length of the pier, we could say it's the entire width of the bridge, which is 30 feet. Or we could say, for instance, it doesn't extend the last 3 feet, so there's a little overhang on each side, maybe something like 24 feet. Oops, 24 feet. Let's just go with that. Angle of attack, K2. This would be in the degrees. I'll just assume the water is flowing straight at the bridge, so there's no angle of attack. We'll leave that value at 0. Okay, so we still need to get the depth and the velocity just upstream of the bridge, upstream of the pier. So I'm going to go back to my HEC-RAS and get that data. So let's see, I'm going to go to View and then Profile Summary Table. Just upstream of the bridge is right here at River Station 350. Here are my 3 different profiles for 1,000, 3,000, and 8,000 CFS. It's looking for the channel depth right now, and I have water surface elevation, and I have the channel invert. So the difference between this value and this value would be the water depth, but I don't actually have that in this particular view. I do have the velocity, so I'll use these numbers, but instead of subtracting, I'm going to delete this column. I'll just use this column for the depth, which I should be able to add by going to Options, Define Table, click on Vertical Water Surface Elevation. I won't need that. Right here, I'll click on Depth, so I'm searching through the different variables that are available to me, and there are quite a few. If I scroll down a little bit, here it is, Maximum Main Channel Depth. So column 4 and maximum main channel depth, and OK. All right, so this is the new column right here. Here are the numbers I'm interested in: 4.97, 8.60, and 13.67. Okay, I'll go ahead and record those. And then also the velocity for the 3 different profiles: 4.48, 6.25, and 8.25. All right, so let's go back now to the bridge scour calculator. So remember, I'm editing the 1,000 CFS scenario. So for that flow rate, we have a depth of 4.97 feet, and then the velocity was 4.48 feet per second. Now, if I tab off, and then I have some results down below, here are all the results. I'm most interested in this scour depth right here, 6.68 feet. All right, I'm going to repeat that process for the 2 other flow rates, the 3,000 and then 8,000. So I'll just remember this number. It's already saved in the calculator, but you may want to save it externally as well. Okay, so we'll click on OK. Come up here to the next scenario, 3,000, and then come back down here to define Pier scour parameters, define, and then, okay, looks like I need to enter all this data again, 8.6 feet, and then the velocity was 6.25 feet per second. The width was 4 feet. What did I say, 24 feet, and then boom, here is my scour depth, 7.55 feet. So that's about a foot more than it was with the lower flow rate. I'll click OK. One final scenario, I'm going to switch it to 8,000 CFS and then click on Define for Pier scour parameters. The depth this time is 13.67 feet. The velocity upstream is 8.25 feet per second. The width of the pier is 4 feet. The length of the pier is 24 feet. That gives us a scour depth of 9.06 feet. All right, well, that is our 3 different pier scour depths based on all the parameters and conditions and assumptions that we made that went into the model. If I click on OK, we can then click on this plot preview button, and it gives us, an outline here in red of what that scour would look like. It's this red line right here. And then here is the bridge deck, and then the left and right slopes of the main channel. Okay. So that right there would be 9.06 feet. If I changed it to a different scenario, like the 1,000 CFS scenario, and then clicked on plot profile, it looks like a similar outline right here. Oh, it looks like the pier is showing up. I need to fix something on my other 2 scenarios to see the pier right here. But yeah, we can see the pier. And then this would be 6.68 feet of bridge scour specifically at the pier. Now, we didn't add any abutment scour or contraction scour, so we're only seeing the pier scour. So I'll click on OK, or close that up. And then the bridge scour summary table will give us the results for all 3 of our scenarios, 1,000, 3,000, and the 8,000 CFS scenarios. with the scour depth of 6.68 feet, 7.55, and 9.06. So if you run the math, we have the original stream bed elevation and then the stream bed elevation after the scour from the pier. All right, well, that's it for this exercise. We calculated the bridge scour for a pier for 3 different flow rates. And what you're seeing on the screen right now are the results.